Hey everyone, welcome to Simplilearn's YouTube channel. In this session, we will be learning the threads in Java or the multi-threading in Java. But before we begin, let me tell you guys that we have daily updates on multiple technologies. If you're a tech geek in a continuous hunt for latest technological trends, then consider getting subscribed to our YouTube channel and don't forget to hit that bell icon to never miss an update from Simplilearn. Now, without further ado, let's get started with our agenda for today's session. So we will get started by understanding what exactly is multiprocessing. Then we will understand the different types of multiprocessing. Then we will get into the thread, where we will understand what exactly is a thread and how a thread works in Java programming. Then we will understand the multi-threading paradigms, then the thread lifecycle, and followed by that we will get into the technicalities of thread, where we will understand the thread definition and how to access the thread methods and how to run it, start it, and the life cycle of a thread and how to end it. Followed by that we will get into some most frequently used thread methods in Java. I hope I made myself clear with the agenda. Now without further ado, let's get started. Is multiprocessing. So back in the day when the computers were a new thing, the processors had only one single core and they used to execute tasks, or the scheduling of the task was one after the other. One process was supposed to be finished and then the next would come up, right? So now what is multiprocessing? So these days the latest computers come up with multiple core processors, right? Here even the processors are highly powerful, where they can execute multiple processes in one single go, or you can consider they can execute multiple tasks parallelly with respect to each other. Right, so the process of using the complete bandwidth of a CPU to execute two or more computational jobs at a time is defined as multiprocessing. Now, there are two different types of multiprocessing. So, the two different types are basically process-based and thread-based. So, both are completely, similar to each other, but they have some minute differences. What are the differences? Basically, they both execute the same task, right? They take care of two or more mathematical or logical processes to be executed parallelly with respect to each other. What's the difference? Yeah, they might seem same, but the thinnest line of difference is when we look into the process-based multiprocessing, it runs two or more processes concurrently. And threads, they execute two or more threads concurrently. So what is the difference between a process and a thread? Right, now let's assume that you have opened your internet browser and in the one tab you are browsing through your internet, and in a different tab you are scrolling through your social media platforms, say Twitter, Facebook, or YouTube. Right, here those are considered as different processes. Right, you are trying to open up different tabs on your Google browser or any internet browser, and apart from that, let's say you're trying to execute a code and you've opened your IDE, say Eclipse or PyCharm or something. So when you're browsing through internet, you get some source code and try to copy it and try to run it on your IDE. So these are considered as multi-processes, right? Multiple processes. So this is process-based multiprocessing. When you come into thread-based, you just open up one single application. Let's say your boss told you to write down a document for deal, right? When you're processing a deal or you're trying to give a presentation to your client or something, and you are trying to prepare that particular document on Microsoft Word or Microsoft PowerPoint, whichever may it is. Right, and your process is to type in the text or add the information onto your IDE, or let's say you're trying to add the information onto your Word, right? And here Microsoft Word is taking care of multiple things in the background. It is taking care of the spelling, it is taking care of grammatical issues, it is taking care of indentation, it is taking care of font, etc. Right, so here multiple threads are running to execute a single task. Right, this is where you can define the difference between process-based and thread-based. So another difference is process-based multiprocessing requires more time and more memory compared to the thread-based, whereas the thread-based multiprocessing will consume less time and less memory since only one application is running there. And the last difference is it requires separate address space. So the process-based multiprocessing will require separate individual address for each and every process you are running in the background. So one address for browsing through internet, one address for executing your IDEs, etc. And here, when you're running one single application, so one single address space is shared by multiple threads. You will be having one single main thread, and that particular thread is responsible for creating or eliminating any child threads. We will understand this particular process in the next following sections. But let's understand that there will be one single main thread which will start the entire application, and that particular thread or main thread is responsible for any of the future upcoming child threads. Right, so this is the thinnest line of difference between the process-based multiprocessing and the thread-based multiprocessing. Moving into our next subheading, we can see what is a thread. Right, so what exactly is a thread? So here you can see one image, and this particular image can be considered as an application. So let's say you are going to start an application. Let's say you're starting your Eclipse IDE. Then you start your application. This particular processor will start the main thread inside that particular operation or that particular application, right? And that particular main thread is responsible for creating multiple child threads. So the hierarchy goes in this way. When you start an application, that particular application will receive a request or a process from the user. Let's say you're trying to open the IDE, or let's say you're trying to open an existing file in your computer system. That's the request what you send, right? Based on that request, that particular request will be processed by starting a main thread, and that particular main thread will look, is there a requirement for any of the child threads to be created for this particular process or request, and accordingly it will give birth to multiple child threads, and it will get the job executed, or it will get the job done. So every thread will have a job, and that particular job will be inside the thread body, and it will be executed by accessing that particular thread body. So we will look how the fundamentals, or how the process, or how the life cycle of a thread goes on in the next particular segment. Now moving ahead into the next part. A thread is the smallest unit of execution, or a processor allocates time to threads. Every thread has a program counter to keep track of the next duty. Remember I said one single main thread will create the multiple threads or child threads, right? So each and every thread will have a program counter which will take care where to go and what part of the code to be executed, right? Sometimes you call a function and the entire control will be sent into that particular function body, and the main body will be waiting for a response from that function. It can be anything. It can be the data, or it can be the control which comes out of the function after the execution, right? And after that, every thread has a stack to arrange the priority of jobs allocated. Every thread has a set of registers, and every thread has its own unique ID. However, a thread cannot execute itself. It needs a program or a process. You cannot start a thread unless you start, or unless you give a request or any kind of operation to the application. And finally, multi-threading can be only possible on multi-core processor. So if you have a single core processor, you cannot do it. The processor should be capable to execute multiple processes at one single go. It should be capable to finish multiple processes in parallel with each other. It should not have scheduling like one after the other. So that can be possible only multiprocessor based computers only. Now in the next subheading, what is multi-threading? Right, as shown in the above figure, a thread is executed inside a process, and there is context switching between the threads. There are multiple processes inside the OS, and one process can have multiple threads. Remember, I said you, when an application is started, it receives a request, or it receives an operation or a process from the user. And based on that process, request, or operation, the main thread will start the execution process. And that particular main thread is responsible for creating multiple threads in one go based on the requirement, right? So here you can see one application got started, and it started up multiple processes. Process A, process B, process C, right? The process can be interdependent, or process can be individual, or they are not dependent on each other. It is based on what kind of application you're running, right? The process can be dependent on each other, or it can be independent and it can run on its own. So based on the requirement, the context switching happens between the processes, right? So these are the threads and these are the individual processes of process A, process B, and process C. Let's say process A is dependent on the result or the output which comes from process B. Until that time, this particular threads in process A are idle, right? And if say process A is supposed to be giving the output to process B, which is dependent on process A and C together, then the threads in process B will be idle until the control comes to that particular end, right? That's how multi-threading works. That's the meaning here, which says context switching happens between the threads, right? Now moving on to the next subheading. The next subheading will explain us the thread life cycle. Right, we already have a brief understanding how a thread starts, what's the hierarchy of a process, what's the hierarchy of a main thread, then the child threads, right? Now let us understand, let's keep that aside and let us understand the thread life cycle of every thread. Whether it is a child thread or whether it is a main thread, every thread will go through this particular life cycle. Let's understand what's that life cycle is. So the life cycle starts from new, runnable, running, waiting, and dead. This particular runnable plays a major role because every single thread, whatever the thread you define, that particular thread will only have one function, which is run, right? We will be dealing that in the next segment, but now let us understand what exactly each and every one of these stages is having an importance, right? Let's go through the first stage, that is new. The first stage in every thread's life cycle is new. The brand new thread is created using thread class, and thread will be in this state until the program is sent for execution. So whenever you click on the application will start and the new threads are readily dispatched for every process, right? Until the process is clicked upon, until the process is started, these child threads or the thread whichever started will remain in the new state, right? It will not start. Whenever the request is received, then the stage will change from new to runnable. The thread gets engaged with the instruction here. The thread gets assigned to a scheduler, and scheduler is responsible if the threads execute or not. Once the threads receive the execution order, the threads will get into the running state from the runnable state. Here, it will store the potential to execute a task in the runnable state. Once the potential is given the order, then it starts executing the job. The thread starts executing the instruction, and this stage is called as running stage. The scheduler borrows the thread from the thread pool. The thread pool is where all the runnable or new threads are available, and once a scheduler gets the job, it borrows the threads from the pool and gets them running and gets the job executed. And remember, I said in a multiprocessing stage, you will be having multiple threads, and in case if there is a dependency, let's say process A is supposed to be receiving an input or an output or a control from another process, until then the process B will be in idle state. That particular idle state is called as waiting state. So the thread goes into the waiting stage as it is dependent on a different process to receive the control or the input. Now, let's get into the next stage, that is the dead stage. The final stage is where the thread gets killed after the process execution is done. After the termination stage, the thread enters to the dead condition. Let's say the process got completely executed and there is no reason why the thread is still active, then automatically the scheduler or the main thread will terminate the executing child thread or the waiting, whichever the state it is. If the process is done, the child thread, whichever finished the execution, will go into the dead state. So this is the thread life cycle. Moving into the next subheading, we will understand the process of thread creation. So Java threads can be created in two different ways. That is, extending the thread class and using a runnable interface. Now let us understand the first way of creating threads, that is extending a thread class. So far we have understood the thread terminology, what is multiprocessing, what is the different types of multiprocessing, thread and what is multi-threading, etc. And we also know that to execute threads in Java, we need to, execute the thread class, right? And what if you wanted to create multiple threads? Based on the fundamentals of OOPS, it is already evident that you cannot inherit multiple inheritances, right? So far we have understood that to execute a thread, we had to inherit the thread class, which is the superclass in Java. And if you want to execute a thread, you need to inherit the thread properties from the thread superclass in Java, right? Now, let's say we had the process, or let's say we had a dependency where we had to create multiple threads. Now it is evident we cannot inherit the thread class from multiple times for all the individual threads. That's where the interface comes into picture. Now we have something called a runnable interface in Java. Now we will be overriding that runnable interface to get the thread job executed. So you can see here this particular code segment is called as thread definition. So to implement the runnable interface, you will write the class A, which will be implementing the runnable interface, and inside that you will be overriding the run method, which is the only method available in thread interface or runnable interface of Java. And inside this particular run function, whatever you write is considered as the thread job, which can be anything, which can be printing a simple message, or it can be a for loop, or it can be a condition, or any duty, whatever you want to execute in terms of software is called as a thread job, which is always encapsulated inside the run function of the runnable interface. And when you come into thread execution, you create a new class B, which will implement the runnable interface, and inside that you will be having the public static void main string args. So until here you will have one single thread, that is the main thread, which will be called by the JVM. And once you create the new object of the main thread, then a new thread will be generated, that is the child thread, which is responsible for executing the job which is present in the runnable interface, and the main thread will be available as it is. This particular main thread will have the job of executing the objects, or whichever the code you have, the job which is related to the class B, and it will be dedicated to that job only. The child thread which you create, the new thread, will execute the thread job which is in the runnable interface. So this is how you can create a thread by extending an existing thread class. Now let's try to execute an example based on this particular type of thread creation. So on my screen you can see an example for extend method, where we are going to extend an existing thread class and try to create the multi-threading operation. So the thread job here is in between the try and catch block, which is a for loop, which will just run for 4 times until this particular condition is true, and try to print a message thread and the name of the thread, right? And every thread creation will have a 50 millisecond sleep timer. Now let's try to quickly execute this class or code and see the output. So here you have the main thread or the main extend class, right? And here we have the thread creation, or we are calling the start function using the extending method. Let's select the code and execute this particular code. There you go. The code got executed, and here we have the output. The creation of thread 1 and 2 and the thread names. The threads which are running is thread 2, and the threads which have died after the execution is thread 1 and 2, right? So we created these particular 1, 2, 3, 4 threads, and the current threads which are 3 and 4 are maybe in the waiting state or the runnable state, and the 2 threads which are executed or dead are the thread 1 and 2. So with that, let's go into the next type of thread creation, which is the runnable interface, right? Now we get into the next type of thread creation, which is using the runnable interface. It is completely similar. We will have the thread definition, class A implements runnable and public static void main, and here we have the thread job. And when you come into class B, right, remember in the previous method we just directly created the t-start, right, t.start method, and which created the thread job. Started executing the thread job. But when you come into runnable interface, things are quite different. Now here, to access or to start the thread job or to run the thread job, this particular class B will not have the control over this particular thread job. right? You cannot directly add in the start and you cannot directly add in the run method here and expect it to run. So what are we creating is we are trying to create a new object, right? The object of this particular class, and that particular object of this class will be accessed by the thread. So here we're creating a thread again, thread t is equals to new thread, and we are passing this particular object to the thread method, and through this we are getting the start function. T dot start will start executing the thread job in the class A. So this is how the runnable interface works. Now let's go through an example based on this particular way of creating a thread. So here on my screen you can see we have the runnable way of implementing threads, right? We have created an object of the class and we are passing that particular object here, and we are accessing the thread through the start method. And here the job is again simple, just we are encapsulating the job inside the try and catch block, and it is again a simple for loop which should print the message and the thread details. Let's quickly execute this program and see the output. There you go. The program got successfully executed. Again, we have created multiple threads here, 1, 2, 3, 4. The threads 2, 3, 4. No, the threads 3 and 4 are in the waiting state, and or you can also consider that they are in the running state, and the 1 and 2 threads which have completely finished their task are in the exiting stage or dead state. And now let's move ahead into the next part of our PPT, which is about the most frequently used thread methods. So some of the most frequently used thread methods are run, sleep, isAlive, suspend, and resume. As the name itself suggests, the run method is used to do an action. So remember, the runnable interface will have only one single method, which is run, right? So whatever the job you define or whatever the job you construct in the class is run by this particular method, right? And the next one is sleep. So sleep method simply holds a thread for a specific amount of time. If you want to hold the execution of a particular thread, then you can define this sleep method and add the number of milliseconds for which you want to hold that particular thread. Next is isAlive. isAlive can be considered as a Boolean type of method where you can just check if a thread is alive or not. It will return a value which is based on the activity of that particular thread, and you can use that for the further processing. Next is the suspend method, which will suspend an executing thread. Let's say you want to forcefully stop a particular thread, then you can use the suspend method. And finally, resume. In case if a thread is in waiting stage, not in the dead stage, if it is in the waiting stage, then you can start resuming the activity of that particular thread by using the resume method. To have a better understanding of each and every method we have discussed here, let's execute a program based on each and every method. Let's get back to the Eclipse IDE. So now we are back on the Eclipse IDE. So here we have the simple program to help us understand how a run method actually works. So here we are creating the method run, object of method run, which is run1, and here we are creating a thread, right? Remember the implementation of runnable interface where we created an object of the main class, that is the method run, and then we created an object of thread, and then we passed the thread.1 along with the start function to execute this particular job which is inside the main run method, which is the thread job, to print the function or print a message which says thread is running, right? Let's execute this particular program and see the output. So there you go, the program got executed, and here we can see the thread job is being executed, which is print a message which says thread is running. Now let's get into the second one, which is sleep method, and here we have the thread job encapsulated in between the try and catch functions block, or you can say try and catch block, and here we have the sleep method where we are calling the sleep function by providing 500 milliseconds hold, right? So when you execute this program, the thread creation, thread 1 and thread 2, will have a difference of 500 milliseconds. Now let's execute this program and see the output. There you go. The program got successfully executed and the sleep method is being executed here. Right. So with that, let's move on to the next method. I presume it could be the isAlive method. So let's close this console and we have the program here. Now here, isAlive is the main class and the thread job is encapsulated between try and catch blocks. And here we have the start function for starting the thread, and we are passing the isLive method to check if the created thread is alive or not. Let's try to execute this program. There you go. The program got executed and here you can see the run method and isAlive is true. That is, the threads which got created are alive and one of the threads, right, one of the two threads is alive and another is false. And here you can see which thread is alive. Now we have executed isAlive, run, sleep, and here we have resume method. Let's get into the resume method. Let's close the console. So here we are trying to suspend some threads. Here you can see thread number 1, 2, and thread number 2 is started here, and here we are calling the suspend function for thread number 2, right? And again we are calling the thread number 2 again with the resume function, right? And in between these two we are trying to start a new thread which is thread number 3. Let's try to execute this program and see the output. There you go. So here you can see the thread number 3 has been created, right? So the thread which was suspended, it got reactivated again in this particular section, right? And we are continuing again with the number 4, the thread number 4. Now that leaves us to the last method, which is the suspend method. And we already had an example of suspend method in the resume method. All we are doing is just trying to hold or stop one particular method by calling the suspend method. Let's try to quickly execute this program and close the practical session. There you go. The thread number 3 got suspended, right? Now here you can see the creation of thread number 0, the main thread, 1, 2, 3, 4, and the thread 3 which got suspended here, and we again continued with the number 4, right? So with that, let's get back to the PPT. So here we have all the 5 methods: run, sleep, isAlive, suspend, and resume. And with that, we have come to an end of this session on threads in Java or multi-threading in Java. If you have any queries regarding any of the topics covered in this session, or if you require the resources like PPT, demo, and the code used in this particular session, then do let us know in the comment section below, and our team of experts will be more than happy to resolve all your queries at the earliest. Until next time, thank you, stay safe, and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.